Good morning, my dear students. As we were doing exercise 5.3, so I guess we have completed that exercise, but some of the students are facing problem in question number 6 of 6, which says convert the following complex number into polar form. So this is the complex number and we need to convert it into the polar form. So let's do this question. Okay, let us understand. Let us consider z is equal to this, and I have separated root 3 minus 1 upon 2 root 2 and root 3 plus 1 upon 2 root 2, real part, imaginary part. On comparing this with z is equal to r cos theta plus I r sin theta, why we will compare? Because we need to find the value of r as well as the theta just to mold it into the polar form. This is called the polar form and this is called the general form. So from general to polar, we need the things, no, r and theta. So first of all, let us compare the real part with real part. R cos theta is equal to this and r sin theta is equal to this. So first of all, let us get the value of r and then we'll get the value of theta. Keeping in mind the condition that r should be greater than 0 and theta should lie between minus pi to plus of pi. Okay, so I'm taking these. Let us square both the sides. So r square cos square theta equal to square of this one. So using the identity and solving it, you are getting 2 minus root 3 upon 4. Similarly, if you square here, so r square sin square theta, the difference is only of minus. If this gives minus, it will surely give you for the positive one. So r square sin square theta is equal to 2 plus root 3 upon 4. Now add both these two. Take r square common, so cos square theta plus sin square theta will be what? 1. So you are left with r square is equal to this plus this, and when solving you will get 1. So you got r is equal to 1. Now let us focus on theta. What will be the value of it? Okay, so after understanding the value of r equal to 1, now just do one thing. Let us find the value of theta from here. So as r is equal to 1, so I have put the value cos theta is equal to root 3 minus 1 upon 2 root 2. Now I am separating this 2 root 2 with this root 3. So root 3 upon 2 root 2 minus 1 upon 2 root 2. Now see how I am writing this root 3 upon 2 root 2. This root 3 upon 2 into 1 upon under root 2 minus 1 upon 2 into 1 upon under root 2. Can we write like this? Okay, now root 3 upon 2 is cos 30 degree, 1 upon under root 2 is cos 45. 1 upon 2 is sin 30 degree and 1 upon under root 2 is sin 45 degree. Now this is the identity cos x cos y minus sin x sin y. So cos x plus y, 30 plus 45, 75. Cos theta equal to 75. So theta is equal to 75 degree. Keep it as it is. Now you take this, r is 1, so sin theta is equal to minus of, I have separated it and I have written like this. And from here I am getting again the sin 75, but minus sign is there. So we know sin of minus theta is minus sin theta. So minus I am taking inside. So sin theta equal to sin of minus 75, theta is equal to minus of 75. Now if you remember, I have told you that this theta should be same. Now the theta is not same here. This is minus coming and this is positive coming. But we can make them same, with one concept. With what concept I'm saying? Cos of minus theta is what? This is positive only. So this cos of 75, can we write this cos of 75 as cos of minus 75? Because cos of minus 75 is cos 75 only. Now if you compare here your theta, that means whatever you need, that will be attended, that here theta is minus 75 coming. So you can mold this also. Here theta can also be minus 75 because at cos minus 75 you are getting the same value as of you are getting on the cos 75, the cos of positive 75. See, even you can verify from the calculator also. I type cos bracket minus of 75. What you are getting? 0.2588. Just remember 0.2588. Cos of 75, 0.2588. So it's the same. So all the things you got, r is equal to 1, theta is equal to minus 75. Can you write 75 in terms of that is in terms of radian? So 75 into pi by 180, So you will get 5 pi by 12, that is minus 5 pi by 12. So can we write this complex number in terms of that is polar form? So z is equal to, as the polar form says, this r is 1, so 1 multiplied by this will be 1 only, cos of minus 5 by 12 plus I sine of minus 5 by 12. That's it. Okay. So attention my dear students, see the next topic, that is locus region in the Argand plains, that is not included in the latest reduced syllabus. So congratulations. Okay, we'll head to the next topic. Okay, so here comes the next topic, that is square root of complex number, which is very important topic from the exam point of view. Okay, so as you can find the square root of any of the positive number, okay, or any of the real number, similarly you can find the square root of any of the complex number also. Okay, so let me just take one question and directly just make you through that process, how to find the square root of the particular complex number. If you just need to remember the steps, remember the criteria, remember the algorithm of that question, you can easily do all the questions with that. Okay, so let us start. Okay, now try to focus. Really, this is, if you understand the process, no, you will get all the questions very easily, because the exercise is very small and you can do all those 4 questions if you understand one. So the story begins from here. Find square root of minus 7 plus 24i. This is the very first question of exercise I am doing. Consider, let z is equal to minus of 7 plus of 24i. What we need the square root, that is the square root of minus 7 plus 24i. And as we know, z is equal to x plus iy. So this z I am writing x plus iy is equal to under root of minus 7 plus 24i. That means the value of under root of minus 7 plus 24i you will attain by x plus iy, because if they both are equal, then we just only need to find the value of x and y. If we do so, we can easily find the square root of, that means we have found the square root of minus 7 plus 24. So let us go into that process deeply. To get the value of x and y, first let us square both the sides. So x plus iy whole square is equal to minus 7 plus 24i. Using the identity a square plus b square, so I square y square, I square is minus 1, so minus of y square, plus 2xyi is equal to minus 7 plus 24i. Now you compare the real with real, imaginary with imaginary. So x square minus y square equal to minus 7 and 2xy is equal to 24. Just keep it as it is. Now see, this is somewhat a twist in the question which you have to remember and use it in each and every question, and that was, as we know, if I ask you what will be x square plus y square the whole square, so you will tell me x square whole square plus y square whole square plus 2 x square y square. But I'm trying to write in such a way, I'm trying to write this x square plus y square the whole square is equal to x square minus y square the whole square plus 4x square plus y square. Let me just explain you here that what it is actually about. A square plus a plus b the whole square is written as a minus b the whole square plus 4xy. Why? If you just expand it, so you'll get a square plus b square minus of 2xy plus of 4xy. What is minus 2xy plus 4xy? Will it be plus of 2xy? So hence verified. So that is why. And why I am doing this so? Because I have the value of x square minus y square, so that I can put here minus 7. And this can be written as 2xy the whole square, so I can replace this with 24. So that to get the value of x square plus y square, and I can make the two linear equations in x square y square and x square plus y square. Are you understanding this thing? Okay, so in place of this I'm writing minus 7, in place of this I'm writing 24. 49 plus 5 76, 625, and your x square plus y square, you will always accept the positive value. we won't accept the minus of 24. Why? Let me give you the reason for this also. See, this is x square. So even if you have any value of x as negative, after squaring it will be positive. This will also be positive. Positive, positive. On adding, you'll get a positive only, finally positive. So x square plus y square cannot be a negative value. So that is why that will be the inadmissible. So we have to take 25 only. So you have one equation as this and you have another equation as this. See, I have done the elimination also. Took the first equation, then I took the second equation. I just solved it and I get the value as y square equal to 16. Now this x and y can accept both positive and negative. So don't worry about it. So y is equal to plus minus 4. Now with the help of this y is equal to plus minus 4, you correspondingly find the value of y in putting in this one or this one. So let me just put, or you can directly put in this also. You'll get the answer. So for y equal to positive 4, let us find what will be the x. So x will be 24 upon 2 into 4. Okay, I've taken 2y in the denominator. So x is equal to, so 4 2 is 8. This will give you 4 2 is 8, this will give you 3. And for x equal to minus 4, it will be minus 3. So for x equal to minus 3, y equal to minus 3, x equal to 4, y equal to plus. So finally, what we will write here, see, at last what you have to write, x is plus minus 3 and y is also plus minus 4 under root of minus 7 plus 24i. This is the final answer. Square root of under root minus 7 plus 24i is plus minus 3 plus minus 4i. Okay. Okay. So the thing is, I have explained you one question of it. Now I want you to just first of all, if you have understood this thing, then you do the example of this exercise. Okay, after doing examples, just try the exercise, that is 5.5 questions. Okay, if you won't understand, then you just tell me that you didn't understand. We'll take this question again in the next video. But what I want, see, this is purely an algebraic things. We have squared, then we have used some identities, then use the elimination, and then use. So you need to remember each and every step that after this we have to do this, after that we have to do this thing. So that is how, just imprint this algorithm in your mind. Do the examples first. Okay, if provided, just solve it in your fair copy. That would be more that would be very fruitful for you. Then you just attack on the exercise. I'm damn sure you can do it. Okay, so that's it for today, my dear students. Thank you so much. Have a nice day and do practice.